the most powerful video backtracking tool in Taiyuan community, supported online by Qwen3's visual language model. In this field, maybe only Mini CPM is its competitor. Therefore, its leading position doesn't need excessive testing to be justified. Here I've added a video that walks through the workflow for creating tattoo videos, still using the V5 workflow. The latest updates for tattoo videos are already reflected here. We'll also compare the video results. Earlier today, more than 10 hours ago, there was a comparison test between the distilled Dolly model and LightX2V. After reversing the video, the tattoo video still shows strong results. Especially in the generated videos, after the camera zooms in, the blur effect on women's faces disappears, clearly showing how powerful this model is. Then we'll look at the workflow. Here, we're using the Rehabilitation AI Workbench Running 2, best suited for professional users and artists in the field of rehabilitation AI. The content was mainly about modifying some parts of the previous V5 process and made a video protest against it. So these multimodal visual language models with millions of parameters have been out for several days now. Recently, the 8 billion parameter version was officially released online, and in our daily use, it has already proven to be very effective. If it gets any bigger, we'll have to start using APIs. That involves more billing issues. Running this size on online machines is still quite smooth. From the preset prompts, this multimodal model can not only perform tasks like video to text and image to text, but also handle other tasks such as writing stories with no problem. Here, I mainly recommend its video generation feature, so I'll provide more detailed descriptions of this video. Of course, when we generate the video from the following text, detailing it to this level should be. It's unnecessary. We can directly input keywords to simply describe that this video supports Chinese. Then it goes to my text encoder. The process of this text-based video, when viewed today, in my opinion, is quite top-notch and doesn't require major changes. Moreover, this process is perfectly balanced at a critical equilibrium point. This process has been uploaded. Navigate to RunningHub, click AI, or click the link in the introduction to register, and you'll receive 1,200 gigabytes daily. Logging in each day will also give you 100 points. The corresponding AI workflow and one-click AI applications have been deployed online and can now be run and tested online. Then we'll look at today's two newly updated nightly XUV models, one high noise and one low noise, suitable for the image-to-video function acceleration model. Then we'll briefly refer to it as YOO Lianger. The last time on this interface, it also updated the LoRA model, but at that time, when I tested it, its performance was almost the same as the MOE model, so there was no need to update the video here. The MOE model is different from the Llama 2 model. Here, I've divided it into 5 cases. Based on the previous video V5 process, let me clarify. The final V5 workflow is a combination of the MOE2 acceleration model, the 21 acceleration model, MPS-HP's gain, and Bodhisattva gain. See some comparison test results directly. The first one is our baseline, a typical V5 model using the MOE architecture. The 4 results that follow all use LoRA models extracted from our updated distillation large model. Among the next 4 results, personally, I think the second and third ones are better. What about the second result? It simply switched the MOE model. The third result differs from the second one only in the manual input of Sigma scheduling. Following the official numerical requirements and sampler settings, the difference between the two is almost negligible. So the main difference between 12 and 45 is that 12 includes the NOR model with an acceleration rate of 2.1%, which is a model where I set the weight to 3. This helps enhance our dynamics. KJ used 2 at first, and I used 3. The difference between 4 and 5 is that the combined gain from the Pulsar and MPS-HPS models is clearly visible, showing that gain is also useful, so 4 is slightly better than 5. The final decision really comes down to choosing between option 1 and 2. Should we stick with the original MOE model or go for the newly released distilled LoRA model? Let's look at the other 4 results. The task I want to complete is exactly as shown in 1, 2, and 3. The task is to model the 1, 2, 3 equal distribution, but we can see that the dynamic of the first one is significantly larger, meaning the dynamic of our original MOE model is greater. The third result is skateboarding. Comparing it with the first and second, the first still has more dynamic energy. The results from accelerating the second-year high school model are really impressive. It even slides all the way to the beach. It stretches 5 seconds infinitely, creating huge dynamic effects. So if we simply pursue high dynamic range, the MOE model proves to be superior. So in terms of high dynamic range and smooth motion, personally I think today's Model 102 update has more fluid movements, including scene transitions and character action continuity, which all seem more reasonable compared to before. If I had to choose, I'd split it 50-50 between the MOE model and the YO2 model, maybe just to meet different needs. So these are the results from testing this new model in my benchmark process. All conclusions apply only to my specific workflow and may not be applicable to others, since there are too many variables and factors to control here. So most of the time, this channel shares open source models and projects, but closed source models are where RunningHub really shines. It brought down the prices of many popular models, such as V2, Killing, and Wanxiang. Some specifications were even lower than the official published prices. The more you use it, the more you'll realize that saving up bit by bit really saves money in the long run.